Introduction.
Aditya, did you see my specs? I'm not able to see anything without them.
Yes, Grandpa. Here they are.
Now I can see. So how are you today?
I'm good, Grandpa. I want to ask you something.
Sure, ask me.
How do the specs help you to see clearly?
Actually, in the specs, the lenses are fitted with correct measurements. And with the help of them, I can see this beautiful world.
Can you tell me more of it?
Sure. Come with me. I'll tell you more about lenses in our new chapter, Ray Optics and Optical Instruments.
Spherical mirrors. A mirror formed from part of a spherical surface is called a spherical mirror. There are two types of spherical mirrors: concave mirror, convex mirror. The spherical mirror, in which light is reflected from its inner concave surface, is called a concave mirror. The spherical mirror in which the light is reflected from its outer convex surface is called a convex mirror. The spherical mirror has a radius of curvature r, and its center of curvature is located at point C. The geometric center P of a spherical mirror is called the pole. The line joining the pole and the center of curvature of a spherical mirror is called the principal axis. Sign convention. The distances measured in the direction of incident ray are taken to be positive, and those measured opposite are taken to be negative. The heights measured upwards are taken to be positive, and those measured downwards are taken to be negative. Refraction by a lens. Suppose L is a thin lens. The refractive index of the material of lens is N2, and it is placed in a medium of refractive index N1. The optical center of lens is C, and x-x is principal axis. The radii of curvature of the surfaces of the lens are R1 and R2, and their poles are P1 and P2. The thickness of lens is T, which is very small. O is a point object on the principal axis of the lens. The distance of O from pole P1 is U. The first refracting surface forms the image of O at I' at a distance V' from P1. The image I' acts as a virtual object for second surface, and after refraction at second surface, the final image is formed at I. The formula of refraction for thin lens is. This formula is called lensmaker's formula. This formula also holds for concave lens. If the first medium is air and refractive index of material of lens be n, then N2 upon N1 is equal to n. And we know that. So the lensmaker's formula can be written as, this is called thin lens formula. The focus on the side of the source of light is called the first focal point, whereas the other is called the second focal point. Magnification M for the lens is defined as the ratio of the size of the image to the size of the object. M is equal to H' by H is equal to V by U. Example. A 6 cm high object is placed at a distance of 30 cm in front of a concave lens of focal length 15 cm. Calculate the position of the image. Solution. Given U is equal to minus 30 cm, F is equal to minus 15 cm. Hence, from lens formula, 1 upon F is equal to 1 upon V minus 1 upon U. We have 1 upon V is equal to 1 upon F plus 1 upon U is equal to 1 upon minus 15 within parentheses plus 1 upon minus 30 within parentheses is equal to minus 1 upon 15 minus 1 upon 30 is equal to minus 3 upon 30 or V is equal to minus 30 upon 3 is equal to minus 10 centimeters. That is, the image will be formed on the side of the object at a distance of 10 centimeters from the lens. Power of a lens. The power of a lens is measured by its ability to deviate the rays towards the principal axis. The lens L2 has focal length less than L1. Therefore, lens L2 bends the rays more than L1. Hence, the power of the lens L2 is greater than that of L1. Clearly, P is directly proportional to 1 by F. In SI system, the focal length is in meter. The power of the lens is in diopter. Therefore, P is equal to 1 by F in meter, diopter D. Clearly, the power of a lens of focal length 1 meter is 1 diopter. The microscope. A microscope is a device to see nearer very small objects clearly. A simple microscope consists of a convex lens of small focal length. The principle of simple microscope is that if an object is placed between the lens and its first principal focus, the image formed by the lens is erect and magnified. Magnifying power of a microscope. M is equal to D into 1 by F1 by V. When final image is at a distance of distinct vision, that is V is equal to D, then M is equal to 1 plus D by F. When the final image is formed at infinity, then V is equal to infinity. M is equal to D into 1 by F, 1 by infinity, D by F. Compound microscope. It consists of long cylindrical tube containing at one end a convex lens of small aperture and small focal length. This is called the objective lens O. At the other end of the tube, another coaxial smaller and wide tube is fitted, which carries a convex lens E at its outer end. This lens is towards the eye and is called the eyepiece. The focal length and aperture of eyepiece are somewhat larger than those of objective lens. Cross wires are mounted at a definite distance before the eyepiece. The entire tube can be moved forward and backward by the rack and pinion arrangement. Magnifying power of a compound microscope. M is equal to minus V0 upon U0 into D upon Fe plus D upon Ve. Signs here already have been put. Telescope. The astronomical refracting telescope consists of an objective lens system and an eyepiece. However, the two instruments differ in that the objective of telescope has a large focal length and a much larger aperture. Light from the distant object enters the objective and a real image is formed within the tube. The eyepiece, used as a simple magnifier, leaves the final image inverted. When the final image is formed at infinity, the objective lens O collects parallel rays from the distant object. So, an image I is formed at the principal focus FO of the objective. Since the final image is at infinity, therefore, I must be at the principal focus FE of the eyepiece. Thus, FE and FO are at the same place. Magnifying power of a telescope in normal adjustment is the ratio of the angle subtended by the image at the eye as seen through the telescope to the angle subtended by the object as seen directly when both the object and the image are at infinity. The angular magnification is M is equal to minus FO by FE, where FO is the focal length of objective, FE is the focal length of the eyepiece. Did you know? Newton demonstrates that a prism could decompose white light into a spectrum of colors. Hubble Space Telescope helps find the most distant galaxies. Summary. Let us summarize what we have learned. The relation between object and image distance in terms of refractive indices of the medium and the radius of curvature of the curved spherical surface is n2 by v minus n1 by u is equal to n2 minus n1 by r. Lensmaker's formula is this. Thin lens formula is this. Magnification m of the lens, m is equal to v upon u. Power of a lens, P is equal to 1 upon f in meters, diopter d. The combined power of thin lenses with power P1, P2, P3 is P is equal to P1 plus P2 plus P3 and so on. The refractive index of the material of the prism, n is equal to sine of A plus delta minimum by 2 divided by sine of A by 2, where A is the angle of prism and delta m is the minimum deviation. The splitting of white light into constituent colors is called the dispersion. The intensity of light scattered from fine particles, dimensions wavelength of light, is inversely proportional to fourth power of wavelength of light, that is, I directly proportional to 1 upon lambda raised to the power 4. Defects of vision are myopia, hypermetropia, presbyopia, and astigmatism. Magnifying power of a microscope, m is equal to d into 1 upon f, 1 upon v. Magnifying power of a compound microscope, m is equal to minus v0 upon u0 into d upon fe plus d upon ve. The angular magnification of telescope is m is equal to minus fo upon fe, where fo is the focal length of objective and fe is the focal length of the eyepiece.